My name is M. Sai Kiran. I am from ECB section. My topic is high resolution radar, real time signals, and information processing. Introduction. Radar, radio detection and ranging, is an electronic equipment which can determine the range, angle, or velocity of targets by transmitting radio waves and receiving other echoes. Compared with optical system, radar has the characteristics of all weather and all day and has certain obstacle penetration ability. Therefore, radar is widely used in military and civilian fields such as surveillance, guidance, navigation, and remote sensing, etc. Narrowband signals are widely used in traditional radar because the signal generation and processing methods is simple. Accordingly, the amount of acquired data is relatively small and it is easily realized in engineering. In general, narrowband radar works well for simple tasks such as detection and ranging. With the development of electronic devices, there exist high demands for advanced functions such as imaging and target recognition. However, the range resolution of narrowband signal is low, which cannot obtain the fine structure information of the complex targets. Concept. Wideband radar is called 1D high resolution radar, which transmits wideband signals. It is categorized by high range resolution, and range resolution is inversely proportional to the signal bandwidth. There is not a universal definition of bandwidth. In general, wideband is relatively to narrowband. Signals that do not meet the narrowband criteria can be treated as wideband. In the radar field, the relative bandwidth, which refers to the ratio of signal bandwidth to the center frequency, is usually used to distinguish between wideband signals. Narrowband signals are widely used in traditional radar because the signal generation and processing method is simple. Accordingly, the amount of acquired data is relatively small and it is easy to be realized in data engineering. For the narrowband or low resolution radar, the range resolution is larger than the target size. Therefore, the target is located in one range resolution cell, thus can be considered as point target. However, for wideband high resolution radar, since the range resolution is much smaller than the target size, the target spreads over several range resolution cells. It cannot be considered as an ideal point target but an extended one with a series of scattering points. For example, the aircraft is a three-dimensional metal object and the radar obtains the image of scattering points in the incident direction, such as the head, the wing, and the tail rudder air intake engine. The echoes these scattering points distribute in a range window in order to form 1D range profile contains various features of targets which can be used for target classification and fine grained identification. Difficulties of signal and information processing. Target detection and tracking are common and basic problems faced by various radar applications because the wideband radar has large single bandwidth and high range resolution. It can obtain higher measurement precision principle, extract more target structure feature and motion feature information, which is helpful to improve the data rate of target capacity of tracking. However, the range high resolution of characters of wideband radar also makes the object no longer a point target but an extended one, which occupies a number of range cells, bringing difficulties to the target detection and tracking. For the detection application, the echo energy of the target is dispersed to multiple range cells. As a result, the echo to noise ratio is reduced. For the high resolution radar, a variety of detectors have been employed for extended target detection, such as integral internet. So, on the integral internet can accumulate the energy of an all scattering centers of the target. However, when the target scattering center is sparse, the excess noise energy will be accumulated, resulting in the accumulation loss. Detector uses the prior statistical information of the number of target scattering points. It has certain robustness under the condition that there is slightly mismatch. For the tracking application, wideband radar can achieve accurate observation and acquire more information, and theoretically can. However, wideband radar signals also bring new technical problems to the target tracking. The size of range resolution cells decreases with the increase of the signal bandwidth, leading to the increase of the false alarm density in the unit spatial volume. The increasing false alarm density and low scatter signal to noise ratio makes greater demands on the performance of data association module and tracking floating module in tracking. For the characteristics of high false alarm in tracking, the algorithm based on the baseline detection. Back of the filter target location in the information on the detection model. As a result, it can surprise the false alarm through the threshold of spatial variation and improve the detection and tracking performance. Conclusion: with the development of industrial devices, the trend of radar signal and information processing technologies is to achieve higher resolution and faster processing speed. In order to meet more military and civilian needs, the performance of radar needs to be further improved. At present, novel methods and technologies of radar and signal and information processing are hot topics in the concepts of high resolution radar and real time signals and information processing's key problems and solutions are introduced, and the representative systems and experiments results are illustrated with example. High resolution radars in the future direction of development, and the representative system and experimental results are illustrated with examples. High resolution radars in the future directions of the improvements roles in the suppressing targets, angular glint, clutter, and interference so on. However, for target detection and target tracking recognition to enhance bandwidth, not all the case. The bandwidth should be terminated according to the specific target scattering characteristics, which is one of the geoscar in the terms of real-time signal and information processing technology. Thank you.